In this video, we will take a look at how NTFS stores the date and time internally. We will start by looking at the two approaches the Windows operating system uses to represent the date and time. We will then look at the idea of absolute time and understand how it is being used by taking examples of three file systems: NTFS, ext3 and HFS+. Fundamentally, there are two approaches which the Windows operating system uses to store the date and time. The first approach is to represent time in a granular way, which looks like this. Here you can see the time is broken down into its constituents like date, month, year, hours, minutes, seconds, milliseconds, and day of the week. In Windows terminology, this way of representing time is called system time. The system time is a data structure that is available as part of the Windows API and has all the variables that you need to represent time in this above format. You can see that the system time data structure is made up of 8 words, right? A word is 16 bits in size. So to store time using the system time data structure, you need a storage space of 16 times 8, which is 128 bits. You might also notice here that the system time data structure has a millisecond accuracy. You might have seen the system time data structure in many places in the Windows GUI. For example, all these are derived from the system time data structure. One more thing to note is that things like time zone and daylight savings are taken from the registry and applied to the system time before it's being shown to the user. The second approach to represent time is using an absolute value. The date time that we saw in the previous example, the 24th of August 2019, can also be represented by this 18-digit number. So if you look at this number, it's a bit confusing because in no way, shape or form it looks like the 24th of August 2019, right? So what is this number? This number is basically the number of 100 nanosecond intervals that have elapsed since the midnight of 1st January 1601 till the point you are measuring time, which is somewhere in 24th of August 2019. The data structure Windows uses to represent the absolute time is called the FileTime data structure. This is made up of two D words. Each D word is 32-bit, therefore the size of the file time is 64 bits. Now we have seen the two approaches or two data structures that Windows uses to represent date and time. Let's go ahead and think about file systems. When you store time in a file system, which data structure will you use? Will it be the system time or the file time? Let's do a quick side-by-side comparison. We saw that the system time requires 128 bits of storage and has a precision of 1 millisecond. The file time, however, requires only 64 bits of storage and has a precision of 100 nanoseconds. You can straight away see that the system time is user-friendly and easy to understand, but it's not an efficient way to store the date and time, right? The file time or the absolute time is better because with half the number of bits, you get a much higher precision. So NTFS uses the absolute time to store the date and time internally. To break down the idea of absolute time, we can understand it as a combination of three things: the epoch, precision, and size. The epoch represents the beginning of time. So for NTFS, the epoch is the midnight of 1st January 1601. Before this, time did not exist for NTFS. The precision is 100 nanoseconds and the size required to store a timestamp is 64 bits. File systems always use absolute time to store the date and time. On a side note, the Windows operating system has to do a lot of conversion between the file time and the system time data structures. Wherever the time has to be shown to the user, it has to be the system time, and wherever you want to persist the time to a long-term storage, it has to be file time. The Windows API provides two functions to do this, which are FileTimeToSystemTime and SytemTimeToFileTime. Now let's move on and look at examples of three file systems to expand on this idea of absolute time. We already looked at NTFS. So NTFS stores time as a signed 64-bit integer. In a signed 64-bit integer, the largest value you can represent is this. So this number is 9 quintillion, 223 quadrillion, and so on. In NTFS terms, This number can actually be used to represent time in 100 nanosecond intervals till the 14th of September 30/8/28. After this date, all the 64 bits of the timestamp will get used up. Any further attempt to increase this value will cause the sign bit to flip, and the time which is represented by NTFS will become negative. The ext3 file system uses an epoch of 1st January 1970 and has a precision of 1 second, which is very low precision compared to NTFS. It uses a signed 32-bit integer, and the maximum time it can represent is the 19th of January 2038. So if you have heard of the year 2038 problem, this is what people are talking about. The successor to ext3, which is ext4, addresses this problem by adding 2 more bits to the timestamp, and it has also moved to storing timestamps with nanosecond accuracy. So with ext4, the problem has moved from the year 2038 to the year 2446. So basically that's postponing it by another 408 years. So ext4 can be used without any issues till the 10th of May 2446. The third example is HFS Plus, which was the de facto system for Mac OS. HFS Plus has an epoch of 1st January 1904, and it uses a 32-bit unsigned integer to store the time. So HFS Plus has an epoch that starts earlier than ext3, but it can go up to the 6th of February 2040 because it uses an unsigned integer. Basically, it can store larger numbers. APFS, which is a successor of HFS Plus, uses a signed 64-bit integer for timestamps, and it can go much longer. Now, you might have this question as to why there are so many epochs and so many differences in the way date time is stored across different file systems. The simple answer is that the choice of epoch, precision, and size is left to the designer of the file system. And here we can see that the designers of NTFS, ext3, and HFS Plus each had a different opinion on what they thought was the optimal way to store date and time. This is something we have to live with, and this is something we have to understand when we do forensic analysis of these file systems. So in summary, we saw that in Windows there are 2 ways to represent the date and time. These are the system time and file time. So the file time is also called the absolute time. There are 3 aspects to understanding the absolute time. They are epoch, precision, and size. These parameters together decide the maximum date that can be stored in the file system. With that, we come to the end of this video. In the next video, we will see exactly where we can find timestamps of a file in NTFS and what tools are available to decode these 64-bit timestamps.